Hello guys, I welcome you all on this wonderful platform that is BYJU'S exam prep. As you know, this ground zero series is going on and this subject going on is theory of machines. Very important subject, and today's topic is related to the simple mechanisms. So guys, without wasting the time, let us start the session. So in this session, we are going to talk about the inversions of a double slider crank mechanism. First of all, we will get to know what is inversion actually. So my dear, like you know, whenever we are talking about mechanism, whenever a kinematic chain is there, if we are going to fix one link of a kinematic chain, it becomes mechanism. So my dear, likewise, if we have a mechanism with L number of links, so we have L options for fixing a link. So one by one, if you will be fixing first link, you will get one mechanism. Then you will free the first link and fix the second link, you will get another mechanism. So likewise, you can get a group of mechanism by fixing a link every time, one by one, but only one at a time. So this group of mechanism will be said to be as inversions. Obviously, if we are talking about that we have L number of links, we have chances that we can get L inversions. But there is a very important point. If any two inversion have same relative motion, we will be counting them as single only. We will not be counting them as double. So that is a very, very important point. So guys, now what is double slider crank mechanism? Double slider crank mechanism is nothing but a configuration of simple 4-bar mechanism. So when we are talking about a double slider crank mechanism, we are having here majorly 4 links, as it is a configuration of 4-bar mechanism. One is the slotted plate, other is 2 sliders and 1 coupler joining the sliders. So we have 2 sliders, that's a double slider. Okay. So my dear, if we are talking about how many inversions are possible, obviously 4. If 4 links are there, 4 inversions are possible. So my dear, first of all, we will be fixing the slotted plate. When we will be fixing the slotted plate, then my dear, the inversion, what we will be getting, if you will give the motion to one of the slider, obviously the other slider will move, and you will find the coupler, any point of the coupler, if you are going to keep a pencil or pen there, that will be giving you an ellipse, that will be making an ellipse. So that is why this inversion is said to be elliptical tremble. Yes, if we are going to keep the pen or pencil at the midpoint, you will get a circle. But my dear, for infinite points present on a coupler, if we are getting circle for one point, for other points we are getting ellipse. So in general, we will be giving the name as ellipse. That's why we will say that it is elliptical tremble. So my dear, this is the first inversion of this double slider mechanism, where it can be used to plot the ellipse, majorly used in civil engineering applications. Then my dear, we have other options, like we can also keep the slider to be fixed. If we are going to fix the slider, then what we are going to get? When you will be keeping the one slider fixed, then my dear, obviously the slotted plate. The slotted plate is having this, you can say some rectangular sides like that. So one part where the slider is present, that will also not be able to move. Only the sliding motion will be possible for that part of slotted plate. So my dear, what will happen in that case, when you will try to give the motion to the coupler, then my dear, you will be getting that the slotted plate will perform a simple harmonic motion. So that is why this mechanism is used to produce SHM. It is having an application in the power hacksaws. It was given by big mathematicians Scotch and Scotch-Yoke. So that is why this is known as Scotch-Yoke mechanism. And guys, the point is, if one slider is giving us SHM in horizontal direction, fixing other slider, you will get the same SHM in the vertical direction. So the point is, the relative motion will remain same whether you fix first slider or the second. That is why both the slider will be giving us only and only one inversion. So that is why we were having 4 options, that 4 inversions were possible. Now 2 inversion merges. So now we have total 3 options for the inversions, out of which first was elliptical tremble, second was Scotch-Yoke mechanism. First was used to plot the ellipse. Second is used to plot SHF. So in Power Exo machine, you can watch in your colleges, you will find it. In Power Exo, we are using this mechanism. Now we are moving to the third inversion of double slider mechanism. That is nothing but a coupling, Oldham coupling. You know, coupling is used to join the shaft. If you want to join two collinear shaft, we will be using the flange coupling. If you want to use two angularly misaligned shaft, you will be using universal joint. And if you want to join two shafts which are having lateral misalignment, you know that lateral is perpendicular to longitudinal. So if you have lateral misalignment, then my dear, we will be using this Oldham coupling. Obviously, as coupling is joined with both the shafts, so here you can say that coupling has to rotate about two different axes. And we know whenever something rotates at the same time between two centers or between about two axes, it has to slide also. So that is why in the coupling, Oldham coupling will be sliding also, and the velocity of slide is given as d into omega, where d is the offset between the axis of rotations and omega is the angular velocity of driving shaft. So guys, this is the third application, and as I said, it is used to join laterally misaligned shafts. So guys, this was about the inversions of double slider crank mechanism. In the upcoming session, we will talk about some other things like governor, flywheel and all. So guys, if you want such more wonderful sessions in this ground zero series in the animated format, you can write us, you can write in the comment section. So goodbye guys for this particular session.